Dr. Sameer Kamath, Secretary DD R&D and Chairman DRDO, General Manjinder Singh, DSET's PP and FD from Headquarter IDS, Colonel Kuber, Director Aerospace and Defence, Ernst & Young, AVM Umesh, Admiral Srinivas, Admiral Bansal, distinguished panelists, participants from the three services, all the attendees present here, participants from the DRDO labs, academia, industry, esteemed veterans, ladies and gentlemen, a very good morning to all of you, and on behalf of Center for Joint Warfare Studies, as also on behalf of General Arora, CEO, Indian Military Review, I welcome each and every one of you to this seminar on advanced materials in aerospace and defense. Well, it's the second seminar of this kind. We held one last year, and having realized that this critical subject needs to be debated, we are following it up, and I'm sure it will become an annual feature. I think everybody will agree with me when I say that this kind of a discussion on this subject could not be better timed because of two reasons. There are many, but two very important. One is the geopolitical winds which are blowing, as well as the conflicts which are there ongoing, major conflicts in the Euro-Atlantic area as also in the Middle East now. And in the last 2-3 years, with the COVID pandemic, we saw supply chains getting seriously disrupted, and that is where critical and advanced materials, the salience of that was realized by everybody. And the other reason is that concurrently our own country has set in motion very important policies, particularly policies regarding minerals. I think we will be talking more about it as we go. So, talking about these conflicts and the salience of these materials, I mean, if I want to put across the business of war fighting in a very simple manner, so when it comes to dealing with your adversary, I'll be using, various S's to describe. So, 4 S's when you deal with your adversary. You got to sense, you got to share what you sense, you got to select, decide what you want to do with it, and you want to shoot. So, these are the 4 S's which are critical in dealing with your adversary, and there are 3 more when it comes to your own people. So, you have to shield them, you have to protect them, you have to manage their signatures, and you have to make sure that they are well sustained. And all of this we are seeing in the ongoing Ukraine conflict as also in the conflict which is just broken out in Gaza. All these 7 things that I have spoken about are very critical. Essentially, what are we trying to do? What does any side try to do? They want to gain an asymmetric advantage, and it's all about payloads and platforms. So, what do you want in these payloads and platforms? You want effectiveness, you want reliability, you want size to weight ratios to your advantage, you want this to be there in any kind of harsh condition and varied geographic conditions as particularly our country has. You want these systems to be smart, you want them to be intelligent, you want them to be adaptive, you want them to be self-healing, you want them to be absolutely aligned to your swap C requirements, size, weight, power and cost, of course. So, all of this and more is delivered by advanced materials. And what are these? A huge bouquet. There are metals, there are alloys, there are composites, there are ceramics, and there are polymers, and of a variety of nature. So, you have nanomaterials, you have metamaterials, you have multifunction materials, and you have also increasingly biomimetic materials. So, there is little wonder then all of this is being leveraged in everything which on the battlefield today, whether there are aircraft, ship, tanks, guns, missiles, hypersonic systems, munitions, drones, communications, stealth, energy storage, semiconductors, computing requirements for artificial intelligence, quantum technologies, space, what have you. But having given you this huge long list, let me also add that this is only a very small part of what the advanced materials do for the humankind in society. There is much more. There is so much that they do for the society at large, whether these are mobiles, whether these are televisions, whether these are electric vehicles. In fact, that is where the cutting edge payoffs of advanced materials lie. They are the ones who are going to be critical, which is going to be critical in delivering green technologies. So therefore, before we listen to the esteemed distinguished guest on the dais, I just want to very briefly put into context the discussion that we are going to have today, and I will just do it in this manner that I will just flag certain challenges and then I will share with you what we have done so far very briefly, because more of that will be shared by all the distinguished speakers, so that we can all of us understand the gaps that we are going to be discussing. As far as challenges are concerned, as I said a while earlier, that a very serious note has been taken of critical and advanced materials by every country, big or small. So every country, right from United States to Australia to France, Germany, Japan, everyone, they have got critical material strategies and policies. As far as we are concerned, we have also recently announced our minerals, critical minerals, announced 30 of them. Okay. We have not actually announced a critical materials strategy or policy, but then we have spoken about minerals, which are the critical ingredients for the materials as such. The challenge as far as we are concerned, I will just give you some figures. They might be at variance with some of the others because you do not get exact figures. So it is said that we have spent in 2022 about close to $2 billion worth of imports of advanced materials. Now this pales into insignificance when you take into consideration the fact that overall every year India imports are over $700 billion. So $2 billion is insignificant in terms of amount, but in terms of the criticality of the materials, it is everything. Nickel, cobalt, superalloys, and the most critical part is that majority of this comes from a potential adversary. So that is where the criticality lies. Talking about titanium alloys, the LCA has a significant import content, and with about more than 45% of the airframe is made up of carbon composites. And just to give you a parallel comparison, the Rafale has got about 70% of its wetted area, the area that comes into contact with the airflow, as made of composites. So now increasingly when we have more indigenous helicopters, Tejas Mark 1 Alpha and more of that ordered, Tejas Mark 2 coming up, and we have AMCA, and possibly also we will have the MFRA coming up. Okay. All of that put together, within every AMCA having about close to 1.2 tons of titanium alloys, the requirement of these is going to go up meteorically, right. And you also need to factor hundreds and more of commercial aircraft which are coming in. We have just talked about the order books. And then there is much more happening. We have indigenized most of our systems, and we have already announced more than 5 positive indigenization lists. All that totals up to more than 500 systems and sub-assemblies, and add to that about 4,660 and more systems and sub-assemblies of the DPSUs. So all of that is going to add to your critical material requirements, and some of it is going to be in non-metallic materials. Now I am talking about fibers. So you would need glass, aramid and aerospace grade carbon fibers. We must also not lose track of what is happening in the semiconductor industry. As we speak, Indian semiconductor industry is spoken of to be about $27 billion. On to 2030, it is said that it might be getting to about $110 billion. And much of what goes into semiconductors, silicon, gallium arsenide and such like many other materials, hundreds of materials, even critical gases, neon, xenon, much of that is required and it is available only in one geography, majority as we speak. It's the East Asia is the geography where much of it is coming from. We need to be conscious as to how we get self-reliance as far as semiconductors are concerned. And to add to the challenges, we have higher costs of indigenous materials. We have low minimum order quantities because defense systems do not require so much, and this is universal, not just for India. And we have very tardy testing and certification procedures and systems as also facilities. But we have not been sitting tight. We have been taking action to address these. Let me just very quickly recount some of that. So in 2016, the Technology and Information Forecasting and Assessment Council, TIFAC, it gave out a materials roadmap as part of the Technology Vision 2035. Our own DAP 2020 and DPEPP, that is Defense Exports Promotion Policy of 2020, they have also already ushered a lot of corrective policy measures. The MMDR Act of 1957, Mines and Minerals Development and Regulations Act, a very critical act as far as our mining is concerned, has been amended twice very recently, once in 2021 and now once in August 2023. And what has happened? For the first time now, as I said, 30 critical minerals have been identified. It's been opened up for auction to the private sector, as also they are allowed now to sell directly to the market 50%. More minerals, even lithium, have now been deregulated. So all of that is path breaking. In fact, 20 blocks may be auctioned very soon. And there is also a rare earth permanent magnet plant, the first of its kind, which has been set up in Visakhapatnam. So all of this is adding to our capabilities. Global partnerships. Obviously, India cannot ratchet up everything that it does internally. You can't be autarkic. So we are now engaged with the outside world through ISET, Initiative on Critical and Emerging Technologies with the United States. We've also signed the Mineral Security Partnership in June 23 this year with about US and 12 other entities including EU. We've also inked a critical mineral investment partnership with Australia and Kabil, that is Khanij Bidesh India Limited. That agency is in the process. It's already signed MOUs to engage with Chile, Argentina, Australia and more on getting lithium, cobalt and much of these requirements. On the R&D front, we will be hearing from Dr. Kamath himself a lot of success stories. He has personally headed the materials vertical. You have a host of DRDO labs, the R&D engineers, DMRL, DMS RDE, Defense Young Scientist Lab, Smart Materials. You have the solid state physics laboratory, you have the defense laboratory in Jodhpur, and you also have, of course, the Naval Material Research Laboratory. All of them and certain other laboratories put together are addressing our requirements of these materials. And we have Medhani, which has been doing so much, including contributing to Chandrayaan, and it's also now planning to make nickel and titanium alloys powders for additive manufacturing to meet our aerospace requirements. So let me just sum it up all by saying that all this is being done is policy initiatives and innovations which are taking place, but all of that needs to be translated into action, and that is why all the stakeholders are present here in this room today. And we are going to be looking forward to be hearing very grounded perspectives in very focused thematic sessions. The first one after this one is on the materials in aerospace, the second one on naval and the land forces requirement, the third one is on smart and future materials and semiconductors, and the last session, a very important one, is on additive manufacturing. So, we are very hopeful that each one of you will participate with enthusiasm, and even those who have come here to be a part of these sessions, we look forward to very incisive questions from you, and these proceedings are going to be summed up in an action oriented report thereafter. Also these proceedings will be shared with all the military training establishments from Army, Navy and Air Force over 3 days after we conclude. So, thank you so much for your time and attention, and Jai Hind.